Hi, there was a suggestion in the chat box for me to do a short video on the assignment, and so I'm going to give it a shot and see if this will help. We're having trouble getting traction on the fastener assignment, so hopefully this will help. I do expect to see you on the Zoom call tomorrow. Nobody showed up today, and that's a great opportunity to help you get some things answered and get started. So here are the questions we're dealing with. So draw and label a bolt, and its name is 3 parts. And the first, actually looking at the first 2 questions for sure. Draw and label it. You've got a couple places you can go to, and I've tried to open these up, these tabs, to try to make this a little bit faster for you. But I sent a PDF to everybody that had, this is the cover page, and there's like 6 pages to it, so you can scroll down, and information about bolts, studs, cap screws is in print and text, machine screws, self-tapping. So there's one of the answers right there to one of the questions early on. And then here's parts of the bolt. So there's your title of the parts of the bolt. You just have to draw the picture. There is a picture if you scroll down. There's a picture right there of it. So it's included in this packet to reference. And there's some other charts later on. These are just images to show you what the shapes are and the names. There's some different types of nuts. And there's a torque chart. You can use this torque table to answer the question. I think it's about around 12, but it asks for what the value for the torque should be for a bolt that's a given size and a grade. So if you look, I'm kind of jumping around now, but since I've got this on the topic, you can look. So here's the grade, this SAE and the numbers, that's the bolt grade for a standard bolt. Okay. So that'll help to know how hard the bolt is. And then you have the size over here. We go by head size, or sorry, bolt diameter, not the wrench size or the head size, but the bolt diameter, to figure out how tight should we tighten it. And that will come up in foot-pounds out in the middle of this chart. So I'm going to jump back to the questions. So there's question 1. There's that self-tapping screw question, and I showed you where to find that. Thread pitch, it's also in that description pretty early on. I probably went right past it. I'm going to scroll up. I'm going to back out here. So it's in the print. If you look where it says bolt and threads. Now it's in here. You have to look because kids kind of blow past this where it talks about thread pitch. So it will tell you the answer. And also there's a great reference, and I'm looking at the chapter. I think it's chapter 8. I can tell by this label right here, this 8001. This is the first section in chapter 8. And it's talking about thread repairs and fasteners and stuff in this chapter. This is in the Safety and Foundation. It's in Safety and Foundation right here. And then get you to this Fasteners and Thread Repair, chapter 8. And then you go to the actual chapter. And this will have a lot of information for you guys about types of fasteners and thread. It'll get more detailed than what we need, but that's better than not having enough information. So please reference that. Here's metric bolts, a whole section on metrics, how to tell what the bolt grade is, markings on the head in the form of numbers. There's what they call tick marks or hash marks on a standard bolt, like a imperial or inch. It's going to be in fractions of inches. where the metric's going to be in millimeters. Videos, more examples. So look in here. It's awesome as far as just information. You just got to get in and dig around a little bit. So I'm going to jump back to the other questions. So now we get down into question 4, and that's what we talked a little bit about yesterday. I tried to go through that. There is a video, and I will share the link with you, that I've done at school a few days back that'll go through the process as if we were in class. So I tried to just go through the same steps. That'll give you a chance to start it as you need to. To go from a 10 millimeter nut, what size of standard wrench would you need to use that will fit over that 10 millimeter nut in order to loosen it? Question 5 is just the opposite. Now we have a standard bolt, which is a 9/16 wrench size, and what size a metric wrench would fit onto it. So I'm looking for you to show the math like I did on the video. And you'll start off with 9/16 and you'll convert that to a decimal. Take the 9 divided by the 16, and that'll give you a point something because it's less than 1 inch. It's 9/16 of an inch. So it's less than 16/16 of an inch. So it's going to be a decimal point or 0 point something. And then you can multiply that times 25.4, because that's how many millimeters there are in an inch, and you know how much of an inch you have, so you multiply it times the 25.4 millimeters in an inch, and it'll give you the wrench size. So that's what you do for these 3 questions here, A, B, and C. And here's a question about what is bolt grade. So this picture is of the head of a bolt, and I've drawn the tick marks in, and I want you to use that to answer the 3 questions. And you could use that chart at the end of the packet that I sent out to you, where I showed you, I scrolled down and found the torque chart. And you could just, you can also use anything on Google, to look it up. It's fine. What type of nut will lock by itself? This section here, 7, with the question about the lock nut, and 8 and 9. You go to the easiest place, I think, to find that information would be to go to this PDF packet. And there's a section in there on washers and nuts. There's some nuts there. It'll describe the name and kind of the purpose of them, and like if it needs a cotter pin or whatnot, it'll say that. And then we get down into washers, flat washers, copper washers, locking washers. And one of those will be used for sealing, and just kind of read through and it'll pop up for you. I don't want to just flat give you the answer here because it is in print for you. Okay, I know sometimes that's a tricky one. Kids miss that sealing washer, and that's pretty important for fuel and brake lines, anywhere you've got fluid flowing through a line. So then we get into this question here on 10, and this always confuses kids. So I've given you the wrench size of the bolt here, the 7/16, ½ inch, and 9/16. And how to figure out this bolt size for these is hidden right here in the question itself. It tells you the difference between them. There's 3/16 right there. So don't miss that. That's the key to calculate what size of bolt would take a wrench that's 9/16 in size. And then you come up with your answer. Again, show your work. All you have to do is start with your original number and either add or subtract the 3/16 to come up with your answer, and you'll have it. 11, calculate the following torque values. That's also in a video, the second video that I'll include. The name or title, and you can cut and paste it, that I did in the class, so it's on the whiteboard and helps you to solve those 4 questions there. Please show your work so I can tell if you got it right, I can see how you got to that correct answer. And if you missed it, we can figure out what maybe went wrong in your process. So now we get down to 12. Why should it be tightened? That I'm sure you can look up. I don't know if there's a real good explanation in the packet. We generally include that in our classroom discussion. So there's 2 reasons why you want to torque a bolt. And then the torque specs for 9/16 bolt. So it's question 13 that I alluded to earlier. And you can look up in that chart and, you know, find the grade of bolt and the size of the bolt on the left-hand margin, and you just, where those come together, you use it like a times table. Come down from the bolt grade and across from the bolt size, and where those 2 lines meet, that's your torque. Torque specification. So 14, now there's a chart that I believe is included. I'm going to look and see if I got it included in the packet, and if not, we should be able to find it on the Sterrett. So these late questions, 15, 16, this is not a good chart here. Okay, so for this one, I'm going to ask you, I'll include this. I already put it in the Google Classroom. And if I can find it now, Sterrett. Okay, so Sterrett is a huge manufacturer for fasteners and bolts. And this chart that you're seeing will tell you there's 3 columns right here, another 3 columns between the red lines, and then another 3 columns over here. And what these are for, these are all drill sizes. Starts off with an 80. If we were in the classroom, I'd show you our black drill index box that has all these drill bits in it. Drills come in numbers that you see in this column here. There's a fraction thrown in there. There's a 1/64th because it and this is their size. So an 80 drill bit's 13.5 thousandths. Drill bit 79 is a little bit bigger by what, about 1/1000th of an inch. So it's just a tiny bit larger. And then the 1/64th drill bit would fit between the 79 and the 80 drill bit for size. So if you see these numbers, they get smaller, the drill bit size is getting larger. And that's how these numbers work here. If you're trying to drill a hole to thread a bolt into, which would be an assignment if we're at school, you're going to drill a hole of a certain size, a specific size, and then use a tap to cut the threads into the metal so that the bolt will then thread into that hole that's now threaded. So this 3rd column that you see I'm moving the mouse up and down in, this is where you figure that part out. So I'm just going to grab a random number here. So let's say I have a 1/4 inch bolt, and I'm going to build a bracket and use 1/4 inch bolts to hold this bracket together. Now there's thread pitches, and that's part of your assignment earlier. Here's 2 different thread pitches. So this is a 20. Here's a 28. Notice they're both connected to a 1/4 inch bolt. This is the size of the bolt here, 1/4 and 1/4. And depending on what the thread pitch is, how many threads they have, determines what size of drill bit we should use. So I think that might even be one of our answers. I'm going to hop up to a different one. So I just gave you a hint there. So let's say it's a 3/8 bolt. I'm going to move in a little bit. It's a 3/8 bolt and it's a 24 thread pitch. So now I decided I'm going to use 3/8 bolts, and they're a fine thread. They have a lot of smaller threads on them. To drill the hole, the proper size, I come right across to the left and I would select a Q drill bit. And in the drill case, they would have letter drill bits also. And I'd look for the one that's labeled Q. I'd pull it out of the box, I'd put it in the drill bit, and I'd drill a hole in the metal. And that drill bit size is 332 thousandths. So that's how big the hole would be, 332 thousandths. Then I would take the tap, which is the part that, and you might even be able to find this on the CDX too, but just look up tap, thread tap on Google Images, and you'll see what they look like. It'll make sense to you. So I'll use that 3/8 by 24 tap. I would thread it into this hole that I've created with the Q drill bit that starts out at 332 thousandths of an inch. And when I get done, I would have a hole with threads in it that would accept a 3/8 by 24 bolt, 3/8 by 24 thread pitch bolt, and then I can bolt things together. This is how you use the chart to answer those late questions. And I'm going to pop back over to the questions. So 14, we're trying to drill a hole. It's 295 thousandths. What's the drill bit you'd select? So you go to that chart and look up, go down till you find the 295 thousandths. Not there. That's not what I want. It is a sterret. Yes, that's what I want to open. Come on now. Work with me here. So I'm going to look in this chart, this here column for 295 thousandths. So you just work your way down. When I find it, if this was the number I'm looking for, the 140.5 thousandths, I would use drill bit 28. So in this case, a numbered drill bit. So that's how you look for or solve that question. Where did the questions go to? Okay, so let's go back down. We're getting near the end here. 15 is a little tricky because we don't have anything. All of our fractions are going to be a whole number 1, a 1/2 of an inch, a 1/4 of an inch, and they just keep getting cut in half. So we don't ever have a 1/5 of an inch, but change it to a decimal, and now we have common ground, because this chart that we were looking at in that sterret chart, drill chart, has decimals on all those drill bits. So now you can figure out what size of drill bit to use to come up with a hole that would allow a bolt that is a 1/5 of an inch in diameter to go into it. Okay. Same thing, you can use a chart to try to find out what a number 8 fine threaded screw is. Now, a number 8 screw is a small screw because anything large is a fraction. When we get down to a 1/4 of an inch, anything smaller than a 1/4 of an inch now becomes a number. They don't use smaller fractions. They wouldn't go like an 1/8 of an inch. They would go like a 10 or a 12 or a 6. So if you're standing in the front of a bolt bin in the hardware store, you're going to find that all the small ones are numbered. And when they get up to 12, the next step is a 1/4 inch. So and this will be on the chart, on that sterret chart. So here you're going to drill. What do you pre-drill a hole to make threads for number 8 machine screw? Go back to that same place on the chart that you just looked up this information for the number 8 screw, and then you'll go across to the left and find out what size of drill bit you should use to create the threads. Decimal equivalent for a 32nd rounded to the nearest thousandth. So you figure out what this fraction is equivalent to in thousandths and carry it out 3 decimal places. And 19. Now a lot of kids miss this because they don't really pay attention, but go to this sterret chart, and I think this will work because I wrong one. So what I want to do is to find, where is it, 700. Oh, this chart's not going to work. So I may have to find another chart for you and see if I can get that sheet included. I'll try to add that because this only goes up to 0.578, and I think my question was 0.785. So I will adjust that and try to get another chart that'll go up high enough for you. So what you're trying to do is figure out which fraction is closest to the number I provided for you, the 0.785. So that's it for the worksheet. Don't forget the videos to help you, and also the CDX chapter will be very, very helpful. And I expect to see you on the Zoom call if you have questions. That's the time to go over this. You get almost one-on-one help. If no one else bothers to come on, then we can go over and give you some more specific help. So don't put it off. Hope this helps you guys. Look forward to seeing you. Bye.